Welcome everybody to today's session. We'll be talking about how to grow your Kubernetes Wingspan with VMware Tanzu. My name is Kenny Coleman. I am an open source and Tanzu Kubernetes Grid technical product line manager, technical marketing manager, a few different words for how to describe me, but you can go ahead, you can follow me online at Kendrick Coleman, as well as I got some code samples, everything like that on GitHub at KACold2. Now, I want to talk and really set the stage today because we have to figure out exactly why we're talking about growing our Kubernetes Wingspan. I've given plenty of talks before about how to utilize TKG and other open source tooling to actually start building Tanzu Kubernetes clusters. So what does it look like to actually start spreading Kubernetes across multiple geographies, across multiple data centers? And that's really what we're going to look at today. And really, how do we visualize it and how do we kind of compact that all into a view that we all kind of know and understand and recognize? And so we look at this because the map BU, which we're in right now, is focused on modernizing those applications. And our mission is really trying to catalyze the enterprise transformation through the software in itself. And we know that we're succeeding in this mission because our customers are achieving some of the most important business outcomes through software today. And there's a few desired outcomes of what we actually want to get with this. First is that enterprises feel pressured to actually start providing more compelling digital experiences for their customers in order to grow revenue. And they do this by reducing the time it takes to convert a lead, perhaps into software production that could impact their business. Second, it's also difficult to innovate at the pace and scale of what the open source community actually is doing. So we want to make sure that we are protecting the applications themselves from a growing number of vulnerabilities, as well as knowing how to scale it within ourselves and our processes. And finally, enterprises want to take advantage of the innovations that are coming from a competitive cloud landscape. So whether it's coming from vendors or open source competition that's out there, we're going to figure out how do we kind of bring all that together. And this is proving to be slower and more complex. And really, it's making it almost an expensive journey for most that are trying to get into it. And so for these reasons, it's not surprising that we see a lot of survey results showing that 78% of CIOs have application modernization at the top of their priority list. And unfortunately, this was also a top priority last year, yet 48% of those CIOs responded they haven't made any progress over in the past year. But why is that? Well, because there's an overwhelming number of choices on how we can actually take our applications and how we package them into a new type of platform, or how we can get running into our existing type of platform. And this is because you're running applications across a large number of teams and hundreds of applications. And so the complexity just grows, and the trajectory at which you can go is just at a very slow pace. And each application in the portfolio typically has different requirements for scaling, whether they need to have reliant on legacy type of infrastructure. And so it makes it really expensive to support. And one of the most important applications are the legacy monoliths, and they're loaded with technical debt. And so how do we start bringing those over into the new world as well? And so for those reasons, we look at a few different things. We want to figure out how do we move towards modern apps with greater velocity, and how do we operate our modern infrastructure? And we want to do this with stability at scale as well. And so we know that inside of VMware, we've been doing a lot inside of virtualization and the software-defined data center space for a long, long time. And nearly 80% of all enterprise workloads today run on some type of VMware technology. So it's around 70 million workloads that are out there, to kind of put it out there for you. And with the acquisition of Heptio, we've now become a top contributor to the Kubernetes community. And as a steward of the Spring community, we've seen a lot of things that are leading in the microservices framework for Java, Spring Boot, so on and so forth. And there's, at this point, over 1 million containers that are running utilizing a Tanzu application service today. And Pivotal Labs in itself has nearly a 30-year track record of enabling enterprises to actually transform how they're building software. And so from this list of logos here, I'd like to share just a few small things of kind of like where we kind of see these things moving here. And we look at this because most successful customers are starting to modernize their applications with a focus on the velocity, like how fast can you get the applications currently iterating, or how fast can we move to production. And they're also modernizing their infrastructure at the same exact time because they want to optimize for stability and consistency that's going to be happening across environments, whether it's cloud or inside your own internal data center. So we have to look at this and look at the Tanzu portfolio and figure out, really see where this all fits in, because Tanzu has the most flexible portfolio of products to actually help you modernize your applications. And we can start with a path that kind of works for you and your organization. So if you want to modernize your private cloud, we can help you do that. If you want to extend that into the public cloud, we can do that as well. And so your first priority about getting software faster is that we have to figure out how do we modernize the applications themselves to actually move down this new path of pushing to production. And maybe you want to make it easier for developers to actually deploy to the cloud, and we can help there as well. But the good thing is that we can help you in all of these kind of facets, and we can identify the priorities and actions for you to follow up and where we need to actually help you with those as well. So let's look at how we're actually modernizing the infrastructure. Well, really, when we look at the amount of support that goes into it, it needs to have both the existing applications and the new cloud-native applications underneath of it. So we give developers this self-service access to multi-cloud infrastructure and platform services. Then we have to adopt a next-generation platform that addresses the specific needs of what we want for our applications as well. And variations in Kubernetes distributions limit that workload probability or that workload portability at the same exact time. So we have to give developers access to the infrastructure and the platform services that they want across multiple clouds. And so when we look at the adoption framework here, really what it's coming into is that we have kind of like three buckets. So you have the integrated infrastructure services. This means that we have to have our infrastructure rely on APIs that we can utilize to actually self-service virtual machines and the infrastructure that's required to actually stand up and get ready to utilize our applications. And this does it in the form of things like vSphere pods. We've got Tanzu Kubernetes Grid. We've got all these things that we can actually create this unified platform that not only just a developer can consume, but as well as an operator knows how to take care of as well. Then you have multi-cloud Kubernetes. Now this is the hard one because we know how difficult it actually is to stand up Kubernetes and actually to use it. So we have to figure out how do we create this consistent environment that extends Kubernetes, that we can utilize it in a private cloud, in a public cloud, at edge, and we can have it consistently be deployed and automated at the same exact time. And we can utilize this, again, across multiple clouds. And then you have multi-team management. How do you take in all these clusters that we are building? Because when I mention this is that usually when we talk to any customers is that they're not doing one Kubernetes cluster. It's not like the vSphere days where we would just take like 32 hosts, throw them in a cluster, throw a bunch of workloads on them, and let them start running. Instead, what we do is we have lots of pockets of Kubernetes clusters. And this could be because every developer has their own Kubernetes cluster. It could be because every business unit does, or it could be a separation of security policies. It's whatever it is. Now what we want to do is figure out a way, how do we visualize the 10 or hundreds of Kubernetes clusters that we have running, and we want to see it all in a single pane? How do we push policy? How do we make sure that these Kubernetes clusters stay conformant? So we want to figure out how we do that as well. And so this is where the VMware Tanzu portfolio starts coming in regard the modernization of the infrastructure in itself. So you've got vSphere 7 with Kubernetes, you've got Tanzu Kubernetes Grid, and you got Tanzu Mission Control. And I'll talk about each one of these a little in depth and really what it's doing for your business. So with Tanzu Kubernetes Grid, the idea here is that we are creating a way to utilize the Kubernetes declarative API to achieve some sort of desired end state. So as an administrator, when I want to provision a workload cluster or a cluster for my developers, what I'm going to do is I'm going to specify, okay, this is what a typical development cluster looks like. And it has this much CPU, this much RAM, whatever it is. And I'm going to apply it to what's my management cluster. And the management cluster is now responsible for going out and actually deploying the workload cluster. And once it's actually provisioned and it's actually built the workload cluster, the management cluster is utilizing the Kubernetes control loop to consistently make sure that this cluster looks just like what I had configured. And so it's utilizing this desired state configuration to keep iterating over it over and over and over again. And so with TKG, depending on where you want to deploy it, today it's supported on AWS utilizing native AWS constructs such as EC2 and Elastic Load Balancers. Then you also have it on top of vSphere. So we have vSphere 6.7 Update 3 that's supported with TKG, or you can have the Tanzu Kubernetes Grid service for vSphere with vSphere 7, which we'll talk about in a minute. We also support Amazon Web Services as a part of VMC on AWS. So it's kind of just like having your own vSphere environment in the cloud and some particular edge use cases as well. And so the goal with what we're building with TKG is that the deployments, the build process, everything that it requires to actually provision clusters looks ubiquitous. It's the same no matter what type of infrastructure you're actually deploying it on. And so this is really where we start looking at the alignment with open source and really what we're getting out of TKG as well. Because this is really built upon other leading open source technologies that are happening with inside the cloud native computing foundation landscape. And so as an administrator, this is really what I get, or what I get packaged as a part of TKG. First is I get Cluster API. Cluster API is going to be responsible for the lifecycle management. And the way that we even got to here is because really what Cluster API does is it is going to be your provisioning mechanism. It knows how to talk to your infrastructure. So Cluster API has providers. So we have providers for vSphere, providers for AWS, so on and so forth. And we plug those in almost like drivers to Cluster API. And so what that's going to be responsible for is actually provisioning and saying, okay, I know how to provision a virtual machine. And once those virtual machines are provisioned, we rely on other open source tooling to actually combine and cluster all those together. So once you have Cluster APIs, a big component, a part of this, we'll start looking at some of the other Kubernetes services that make up this as well. Next, you've got Harbor. Harbor is another cloud native computing foundation project, another big investment from VMware in here as well. And it is your container registry. So it's where your containers reside. Kind of think of it as your content catalog, but only for containers, right? Kind of look at it like that. And this is not a part of TKG in this particular version for 1.0. It will be coming down the line. It is a part of a Tanzu add-on that you can get support for it as well, but it is open source. It's also a part that is supported as a part of vSphere 7 with Kubernetes as well. You also get Contour. Contour is your ingress controller. This is going to be responsible for actually how do I communicate to my applications that are running inside of my Kubernetes clusters. So it is your north-south communication. Contour can be paired with any number of load balancer primitives that you want to support as a part of your Kubernetes cluster. So that could be NSXT, it could be Avi, it could be MetalLB, whatever you choose. In the instance of, say, vSphere 7 with Kubernetes, it's going to be NSXT. So Contour is going to be your controller of how you actually access some of the applications that are coming in and out of your cluster in itself. We also have FluentBit. FluentBit is another packaged piece with this. And what this is allows you to deploy it as a daemon set. A daemon set means that it runs on every single node within inside a particular cluster. So you deploy that to a particular workload cluster. You configure it to say, I want to ship all my logs back to a collector. And that collector could be vRealize Insight, Log Insight. It could be Elasticsearch. It could be a number of different things. But it's another open source tool that we packaged up as well with all the documentation to make it easily accessible. And then you have kubeadm. kubeadm is another component that's sort of underneath the covers. It is another project from SIG cluster lifecycle as part of Kubernetes, where Cluster API comes from. And what kubeadm does is that's responsible for actually doing certificate sharing and actually clustering the nodes that you've provisioned utilizing Cluster API. So it's really happening underneath the covers. And next, we also have DEX. DEX is going to be an authentication component. So if you want to authenticate against LDAP or OIDC, you can utilize DEX to actually do that, and you can have authentication going into your Kubernetes workload clusters. Now, let's look at kind of like a simplified workflow would look like. So we kind of talked a little bit at the very beginning about having vSphere 7 with Kubernetes, Tanzu Kubernetes Grid, and then Tanzu Mission Control. This kind of gives you an idea that we have almost 3 different flavors of how we run TKG today. And what I'm going to show you right now is what we call TKG Standalone, which is supported on vSphere 6.7 Update 3, as well as AWS. So this is kind of the workflow that it works for this particular instantiation of it. So the first thing that we do is we put the TKG binary on our local machine. And we run a command called init, or we're going to initialize it. And so when we do initialization, for this purpose, I'm going to use the UI flag, meaning what it's going to do is it's actually going to pop up a web interface that I'm going to go to and actually start configuring all of the environment variables that are necessary for me to actually start building clusters. So when I do that, I get that. Now there's this thing that's actually provisioned on my own local machine called Kind, or what's called Kubernetes in Docker. This is actually going to create a Kubernetes cluster locally inside of a Docker container running on my local machine. Now what happens here is that it actually gets installed with all the cluster API components, the controllers, the actuators, everything that's needed for this Bootstrap cluster. Now once that Bootstrap cluster is up and running, what it's going to do is actually it's going to talk to my infrastructure, and it's going to start provisioning all of the virtual machines necessary to create what's called my management cluster. And so this management cluster is going to be responsible for all the other workload clusters. Now, the management cluster, once it comes up, it's going to get installed with all the custom resource definitions for cluster API. And then the last thing it's going to do is perform what's called a move. And this move is really just copying the objects from the Bootstrap cluster into the management cluster. Now, once that's completed, we don't need the Bootstrap cluster anymore. It's gone. And then at that point, I utilize the TKG CLI to talk directly to the management cluster. And then from there, I create workload clusters with a simple one-line command, TKG create cluster, give it a name, and then a plan. Now that plan can vary amongst how the cluster looks. It can be a custom plan that you've developed. You can have custom configuration files. You can have a lot of stuff that's variable within inside of this. So you have the ability to create Kubernetes clusters however you want them to look. And really, that's where the flexibility of TKG comes in regards to the standalone type of deployment. So once I specify what I want my cluster to look like, I hand it off to the management cluster. That creates an object in the management cluster. And now the Kubernetes controller is going to run a continuous loop on it to make sure that it goes and provisions that workload cluster to make it look like the desired state that I want. And underneath the covers, we have kubeadm that's getting deployed in these clusters that actually cluster them together and make it look like a conformant cluster. And now let's kind of move on to like that second pillar. So I talked about TKG standalone. Now we're going to look at TKG in the aspect of vSphere 7 with Kubernetes, because we have this, again, a kind of a different flavor for it. Now, the one thing that you get with vSphere 7 with Kubernetes is more options and more features. Now, you also get a sort of like native approach to what you would typically look at as a vSphere or a vSphere administrator. So you have your access through the vCenter UI. You can visualize everything. Your components that actually get provisioned have different icons inside of vCenter, so it's easy to see as well. But if you want to actually go and deploy clusters and have your application owners take care of it, they can have CLI access and provision workload clusters just as you could. So from the infrastructure up, as an admin, I have visibility and control over the resources that are defined within inside of my infrastructure. And from the application down, as a developer, I have access to all of the environment that I need to provision resources. And I do this through native constructs that I would just see that look like just plain old Kubernetes for me. So digging into this a little bit, as I mentioned, you get the Tanzu Kubernetes Grid service for vSphere. This is the same exact idea as standalone. However, instead of creating what's called the management cluster in the standalone, we have what's called a supervisor cluster. Really, it functions as the same exact thing, except you're actually provisioning your supervisor cluster through vCenter. So you just do this through a typical vCenter fashion and saying deploy it. Now, once your supervisor cluster is up and running, that has all of the custom resources that are required to actually go ahead and provision the Tanzu Kubernetes Grid clusters or your workload clusters. So as a user or an admin or a developer, it doesn't really matter. Anybody that wants to have access to create clusters, they can. You utilize the binary that's utilized for vSphere 7. You log in utilizing vSphere SSO, and from there, you start provisioning clusters, just as you would as with Tanzu Kubernetes Grid service. Now, the one thing about TKG in both of these aspects is they share one thing in common, is that these are fully conformant Kubernetes clusters, meaning that there is nothing that's additional that's installed in these clusters. It is just enough to make sure that it is functional and it is normal, and it has access to say like, okay, I can create persistent volumes on my clusters because it's been configured with the container storage interface. So it knows exactly how to talk to vSphere and provision volumes to actually have persistent data. And at the same exact time, it's also provisioned with CNI, so you know that east-west networking is going to be working at the same exact time. But really, that's really where the commonalities really fit with TKG is that, and one of the biggest benefits is because if you have something that runs in Kubernetes today, you know that it can run inside a Tanzu Kubernetes grid cluster because we're not changing anything. It is just a blanket Kubernetes cluster. There's nothing custom or anything like that at all. And so as a VI admin, I can actually come in here and I can really say, like, this is what I want my template to look like. These are the versions of Kubernetes that I want to support. And then I can also do quota management, right? Resources. It's a huge benefit because I don't want my developers to go and say, okay, I'm going to create 50 clusters because there's only a finite amount of resources for it. So I can actually define what that resource quota actually looks like. And as somebody that is a developer and wants to own a cluster, they have full control over it, right? They have full control of actually what this looks like, how they integrate with it, how they interact with it, how they're shipping logs out of it, whatever they want to do with it, it's theirs. So the application owners now own the Kubernetes cluster themselves, which makes a really good separation and delineation of exactly what's a vSphere admin supposed to take care of, what's a developer supposed to take care of. Now you also have what's very unique in here is the vSphere pod service. This is something that is only available with vSphere 7 with Kubernetes. And this allows you to create a pod that runs in a small VM wrapper. Now, this is for a few different use cases. So one is that it is very performant, meaning you're going to get a lot more resource utilization out of it because you're not necessarily running it in a series of like tiered VMs, but instead it's running in kind of, like I said, a small wrapper. You also get more isolation and more security because if you're running, say, in a Tanzu Kubernetes grid cluster, you are deploying containers on, when I say containers, like we're talking like multiple or hundreds of containers in a set of virtual machines. And so really the only sort of security boundary is if you want to utilize namespaces or the security boundary of the virtual machine itself. Versus something like the vSphere pod service is that as a virtual machine, you're now setting a new boundary of really what the security isolation or the resource isolation actually looks like. And as a virtual administrator, I can actually visualize this pretty easily with inside of vCenter. There's an icon that makes it really easy to kind of see. So I get a lot of visibility into the workload as well. Now you also have the virtual machine service. This is just as you could expect. It's deploying virtual machines. However, the neat thing about this is that we take this concept and we apply the same thing we've done to Kubernetes, to Tanzu Kubernetes grid clusters, to vSphere pods, and now we're applying it to virtual machines. So as a DevOps person or a developer persona, and I want access to a virtual machine and I want to kind of act like it's an infrastructure as a service, I can do that, right? I can utilize the command line to actually go and create that virtual machine and deploy it. But as a VI admin, I actually have to create that VM class that somebody actually can utilize. And as an admin, I can also manage what that image looks like as well. So it makes it super easy to kind of understand exactly how I can go and utilize this as an infrastructure as a service type of offering. Now, one of the other cool things that's available with vSphere 7 Kubernetes is the idea of vSphere namespaces. Now, the namespace is starting to allow multi-tenancy, and you're doing this at a few different ways here. I'll kind of build out the slide so it kind of makes sense. So with inside of my SDDC, I can provision multiple supervisor clusters. These are your management clusters, as I had mentioned before. And so your management cluster is responsible for whatever it's managing, if it makes sense. Now, with inside of that management cluster, I can create those vSphere namespaces. This is, again, it's going to be your isolation, and it's going to isolate not only just the containers, but as well as the Kubernetes grid clusters and the vSphere pods and virtual machine templates, everything like that. You can define that all inside of a specific namespace. And so at this point, as I'd mentioned, I can deploy the pods there. I can deploy multiple namespaces. As a VM operator, if I have that as a part of my supervisor cluster, I can then deploy virtual machines as a developer because I'm providing that as a virtual administrator. And I can also enable the Tanzu Kubernetes Grid service, which allows me to actually create Tanzu Kubernetes Grid clusters running inside these particular namespaces. And these Tanzu Kubernetes Grid clusters, they look just as we had talked about before. So you get your control plane nodes, you get your worker nodes, and you're off to the running and you're off to the races. Now, the difference between, as I mentioned before, is that the Tanzu Kubernetes Grid clusters provide you conformant clusters versus something like the vSphere pod service, where it is kind of it's an adaptation of what we're delivering. So the other kind of thing we look at this is like, okay, now we have tens, if not hundreds, of these Kubernetes clusters starting to come up and start looking at it. Like, so really we start looking at the operational toil. If you're manually managing Kubernetes running in multiple clouds, your world is going to look something like this screen. So you're going to have multiple screens, cluster consoles, and you may have multiple role bindings on how you actually access them. Now, once you get a role binding up, you might have to do that over and over and over again to actually have consistent access across all of them. And you're probably got to keep track of ticket-based systems, and operators are probably going to lack the visibility to actually have to manually configure things to actually go and look into the clusters themselves. So as a person being in IT, how do you manage this fragmentation in a way that isn't going to like impose limits on what your development teams can do, but how do you enable them to actually move faster and deliver Kubernetes as a service? And you don't really want to limit them, because we don't want to sit there and look at all these consoles every single day to figure out this is how we manage things. And so this is where Tanzu Mission Control comes in. So TMC for short, it's one of the cornerstones of VMware's portfolio. And what this is now providing a way to have a single point of control to manage Kubernetes across multiple teams and clouds. And so with TMC, you can have developers get their self-service access to the environment if they're to deploy their applications, say on AWS, while operators or VI administrators, they want to have a centralized, visible point of control to actually monitor the health of all the clusters that are actually running. But at the same exact time, you want to not just monitor the health, but you want to manage things. You want to manage configurations. You want to manage those policies on how they're actually, what they're doing and what they're running. And so when we look at this, we have a few different things. So on the provision side, so today, of course, TMC supports AWS. We're going to be supporting more of those as a part of cluster lifecycle with inside of TMC. Now, really where we get into more of this is the attached side. So with the attached side, we can take pretty much any kind of Kubernetes cluster that's been provisioned. So whether you're in AWS, whether you're in vSphere, whether you're in vSphere 7 Kubernetes, whether you're in GKE, you're in Rancher, you're in whatever you are, you can adopt these and you can have a visualization of any Kubernetes cluster across your entire footprint, if you will. But now once they're inside here is that where you can actually start doing really cool things. So you can really start worrying about how to control policies. How do I do identity access and management? How do I set security configurations and policies? And how do I audit all this at the same exact time? And there's other integrations in with things like Wavefront and Cloud Health and NSX Service Mesh to actually start tying all these together, and as well as giving you some of the observability to actually get metrics from all these at the same exact time too. And so this is kind of an idea of what it looks like to actually manage any kind of Kubernetes cluster. So as an admin, I actually want to go ahead and I'm going to get on an authentication token from TMC. Now, once I have that authentication token, I set that and I say kubectl apply, put that authentication token in there. And what it's going to do is it's going to apply a new set of custom resource definitions into the cluster. And as you can see here on the slide, it's going to have a few different agents it's going to install. And once it does that, it's going to start syncing and sending information to my TMC instance. So I can now start bringing in all my clusters and start really looking at these all different types of resources. And I can really start managing all the namespaces that are across all the clusters as well. Now, the other cool thing here is that we can do policy. Now, policies can be applied to a few different places. They can be applied to orgs. They can be applied to cluster groups as well as workspaces. And some of these policies can be applied to cluster groups. So whether you're an IT or an operations team, these cluster-wide configs are going to have policies that will change over time. And so these policies have to be applicable to the workspace and the namespaces that they will be used by the application teams. And so as a team utilizing a cluster-wide policy, you have to define some ground rules. And so application teams are going to have more control for their applications that are being deployed into these particular types of namespaces as well. So one last kind of look at the overall architecture of what you have here. So Tanzu Mission Control is going to be your multi-tenant platform. And this has access to a policy framework, and that can be applied to resource hierarchy. And each customer at this point, and you can have, again, multi-tenancy in here, you're going to have an organization at your root of the resource hierarchy. And the resource hierarchy is going to apply to those clusters that have been provisioned and managed by TMC, and as well as ones that are attached to TMC as well. So you can start bringing in, again, anything from vSphere, AWS to other types of new clusters into here as well. And so here's just kind of a quick screen grab of what you can see of what Tanzu Mission Control looks like. This is, again, giving you that high-level overview of like what's been provisioned by Tanzu Mission Control, what's been attached to it, what is the health of it, and when I say health, like what is the actual memory and resource consumption. You also have what's called conformant. You probably heard that word earlier when I was talking about Tanzu Kubernetes grid clusters being conformant, meaning that they apply the policies that have been set forth by Cloud Native Computing Foundation to kind of be pretty vanilla. And that's what conformant means. So it's going to actually test conformancy utilizing another project in the backend called Sonaboy. And so Sonaboy is actually going to test the conformance of these clusters. And this just means that we know nothing has been installed into the cluster that could jeopardize the way it functions or it interacts. And so this is kind of, again, a layer cake of just kind of what we looked at of how we're transforming the infrastructure in itself. This is where we are looking at actually taking the underlying infrastructure provider, building our local control plane or our management cluster. That management cluster is going to be then provisioning our Tanzu Kubernetes grid workload clusters. And in the world of vSphere 7 Kubernetes, that TKG management cluster is just called a supervisor cluster. That's really the only difference. And so that's what your grid looks like. It's ubiquitous across any type of infrastructure. And from there, we can attach Tanzu Mission Control, and we can start visualizing those workloads. Now, you see this other box to the right. This is Tanzu Kubernetes Grid Plus. This is another add-on that you can actually have more support for open source components that are available as well, but not through customer reliability engineering. That's completely wrong there. But it is more open source components that actually get support through there. Now let's talk about how we're modernizing the applications themselves, because there's a whole other part of the stack that we didn't talk about. Because as an application owner, you're probably running into a few different issues. So you have monolithic architectures. You've got tech debt that you've had built from these monolithic architectures, and you have Patch Tuesday, right? Like, how are we manually taking care of this activity across our entire fleet of things? And so we want to change this because we want to actually start introducing ways to break down a monolith. I know it's probably been beat down before, but we want to start putting in microservices. We want to start containerizing things. We want to figure out, how do we transform applications instead of deploying in 90 days? How can we turn it into minutes? Or how can we turn it into seconds? How do we set up those pipelines to actually make that happen? Because we want to set the automation up to actually make sure a lot of this is being done for us, because we want the most easily consumable way to actually make this happen. And so we look at this again by three more pillars. So we want to introduce production ready and open source software, stuff that has been built by the community, taken internally, and really kind of like smoothed over some of the rough edges to actually make it easily more manageable in-house by anybody at this point. You also want to provide ways that you can easily deploy applications, such as just a simple push. Having that actually removes the need of actually having, how do you package the containers? Exactly, how do we let the application platform figure out how to package a container or package the application best for me? And how do I have observability, not only just to my infrastructure, but also in the applications at the same exact time? Because we want to maintain this sort of like full stack visual component into it as well. And this is where we look at a few more different things. So you have the Tanzu application catalog, the build service, the application service, as well as Tanzu observability. So kind of quickly, just to kind of look at what this looks like. So with inside the application service, there's a few things. So the one thing you're going to see is that this is all built on Cloud Foundry. And the best runtime for Spring and Boot, you have the Spring microservices pattern. You've got the other turnkey microservice operations for security as well. You have native integration into things like Windows and .NET, because you can now use PaaS to run things that were using .NET Core. So you can run your legacy .NET framework apps on PaaS as well through the .NET hosted web core build pack. Now, the other thing is that you want to actually build this for the apps. So PaaS has everything you need to run your apps. And with build packs that manage all the dependencies, the metrics, the loggings, and scaling, it's all done for you, as well as multi-tenancy, blue-green deployments, and those types of patterns, they're all built into it. And then lastly, it is a container-ready PaaS. They support OCI formats such as Docker images, and really the platform itself is built for containers and built on containers themselves. Then you have Tanzu Application Catalog, and this is an offering that combines the content and the tools that allow IT organizations to actually start consuming open source and commercial applications really quickly, because we have a huge catalog of upstream tooling, and it's as simple as a one-click option to be able to deploy that, bring that into your environment, and you can actually bring that into your environment and deploy it to your environment. You can deploy it into your own service catalog, your own repository, and you can deploy it to any type of infrastructure, whether it's on vSphere, whether it's on AWS, or any type of supported cloud. Tanzu Application Catalog can do that. And when I say that, like just a few, when I say that the catalog in itself, we're talking hundreds of applications that make it easy to start consuming right away. And then you have Tanzu Observability. Now, this was the technology once known as Wavefront. Now, this was actually pioneered, again, from the people that came from Twitter and Google. And what they really did is they looked at ways to actually figure out, how do we manage everything from the infrastructure to the application? And so we're not going to go underneath the hood, but we can actually go into a deep dive at a later point. I can hopefully get you somebody that knows exactly what they're doing too. But in a nutshell, Wavefront is going to take in operational data from every layer. And that's everything from the infrastructure to the app itself, from top to bottom, with it has almost over 200 different integrations there. And all this is going to be forwarded to Wavefront Cloud to actually do processing, and it's going to store all of the data for full retention as well. So there's a lot of layers of redundancy built in, load balancing, auto scaling, everything like that. Now, on the user side, Wavefront provides a lot of tools that actually help your teams with inside of your enterprises. So you can be utilized by ops, central monitoring, SREs, SRAs, architects, platform DevOps, really whoever really wants to look at this. It has a nice dashboard. And so you can actually have ways to actually look into it, visualize your statistics from your infrastructure to your application. You can troubleshoot it. You can have alerting, everything that's built into it. It's with inside of Tanzu Observability. And so this is more of a comprehensive slide that kind of show you exactly really where all these fit in. So at the very bottom, we talked about modernizing the infrastructure a little bit. You have VMware Cloud Foundation, you've got VMC, but you have vSphere, right? That's your modern infrastructure. Then we talk about the application runtime. This is TKG. This is where we have that ubiquitous layer that runs Kubernetes really across any type of infrastructure. And then you've got your application service. So that's your PaaS. You've got your build service, and you've got your application catalog. And the application catalog is how we deploy everything. Now, that's the core of what we need to actually have our applications up and running. Now you start looking into, okay, I have more custom built stuff that's happening. So you look into the build side. And so you have the Spring dev framework that comes as a part of an open source ecosystem, but also spearheaded by VMware. You can also bring in other things like .NET and Rust and Ruby and everything like that. And you can build all that on top of these types of application frameworks as well, because the build service really supports a large chunk of any software language that's out there as well. Now on the managed side, again, you've got the service mesh. I didn't really mention Tanzu Service Mesh, but Tanzu Service Mesh is a way that you can actually make sure that you can start connecting the dots between containers that are running in different Kubernetes clusters that might be in disparate places. So that allows them to start communicating to one another. Tanzu Mission Control is your ability to actually take in all the Kubernetes clusters to have that sort of visibility. And then you've got Tanzu Observability. Tanzu Observability is giving you things from the infrastructure into the application itself to actually look at the health of all those individual components. And you can layer it all on with more services on top from Pivotal Labs to actually help you build and get things up and running the way you want. So last, to kind of look at this, there is, again, just kind of a slide to kind of put everything in their buckets of what these particular types of softwares are, what they're doing, and what they can do to help you apply, assemble, deliver, operate, unify, and observe with inside, and really kind of grow your Kubernetes footprint or grow your Kubernetes wingspan across data centers. And so how to get started. If you're just new to Kubernetes and want to get more into it, go check out kubernetes.academy. This is a free resource that comes from VMware. Now, it's nothing is actually tailored to VMware. It's just an idea of how you can get started. You can learn basic concepts such as pods and deployments and replica sets and all that sort of good stuff. So make sure you go check that out. Also, go and check out the VMware hands-on lab. There's all kinds of new Tanzu things that are coming up. So grid, mission control, vSphere 7 Kubernetes. There's more stuff coming for the application catalog side of things. So make sure you go and check that out. And there's more coming to VMworld 2020. With that, I want to say thank you again so much. If you have any questions, hit me up on Twitter. If not, cheers, y'all. Have a great rest of your VBug.